Hello, my all dear students. I am Jerry Wheeler, your mathematics teacher for class 9th, and today we are going to start a very important topic, that is irrational numbers. Today in this video we are going to learn about irrational numbers and its properties. So let's start our video. So my dear students, we are doing chapter number system, under which we are going to learn about irrational numbers. So before going to the definition of irrational numbers, just look at these numbers: root 2, root 3, root 5 and root 7. Okay, or you can say under root 2, under root 3, under root 5, under root 7. What do we call these numbers? Just tell me, what do we call these numbers? Are they natural numbers? Natural numbers we have learned in our previous videos. Natural numbers are like counting numbers: 1, 2, 3, 4, 5, 6, 7. So they are not counting numbers. So we can say that they are natural numbers? No, they are not natural numbers. Are they whole numbers? Whole numbers we have learned about when we add 0 in natural numbers like 0, 1, 2, 3, 4. They are called whole numbers. No, they are not whole numbers also. Okay. Then are they integers? And we have learned that integers are those, or you can say that is a combination of, you can say, negative numbers and positive numbers along with 0 on number line. So they are not integers also. So what are they actually? They are not integers, they are not whole numbers, they are not natural numbers. So what they are? Are these rational numbers? Rational numbers we have learned that for rational number it should be in P upon Q form, which means you can say fractional form, and where Q means denominator should not be equal to 0, and A and B, or you can say P and Q, both should be integers. Are they following that rule? No, they are not following that rule also. So it means they are not rational number also. Are they rational numbers? No, these are not rational number also. So what we can call them? We will call them, these numbers, as irrational numbers. So numbers which are not irrational numbers, we can call them as irrational numbers. So let's learn about irrational numbers clearly. Numbers which cannot be expressed in form P upon Q. In which form? Fractional form, where P and Q are integers, and where P and Q should not be integers and Q should not be equal to 0. So these rules are for rational numbers. So if a number which is not following these rules of rational number, so that numbers or those numbers will be called irrational numbers. What they will call? Irrational numbers. Let us learn more about this definition in an easy language. A number which can neither be expressed as a terminating decimal. Now I have explained you what is terminating decimal in our previous videos. The decimal which comes to an and, like 1.5, it is and. 2.5, it comes to an and. 0.5, it comes to an and. 0.625, it comes to an and. So they are called decimal numbers, or you can say terminating decimal numbers. Okay, so they are saying what? Which neither, what they have used the word neither, which neither be expressed as a terminating decimal. It means we can't express them as terminating decimal, and nor as a repeating decimals, or we can't express them as a repeating decimal also, like 0.333333 and so on, like 0.12121212121212. Okay, so they can't be expressed as a terminating decimal, they can't be expressed as a repeating decimals also. So these type of numbers are called irrational numbers. Okay, so in short we can say the non-terminating and non-repeating decimals. What? Non-terminating, which don't terminates, and which non-repeating means which are not repeating, are called what? Irrational numbers. So short form, it is very easy also. Non-terminating, non-repeating decimals are irrational numbers. Now the collection of rational numbers we are denoting by bar Q. Okay, Q bar also you can say. If you remember that rational numbers, the collection of rational numbers we are denoting by Q only, but the collection of irrational numbers we are denoting by this bar. Okay, so bar Q. Okay, Q bar also you can say. Now see, we have given example root 2, root 3, root 5, root 7. How we can say them they are irrational? Just let me explain you. Root 2, if we divide using the square root method, we are finding square root by long division method. No, so in that way, if we are find the square root of 2, so it will come 1.41421356276237 and so on. It will come on. It will not comes to an end. Okay, In the same way, root 3, 1.7, it will come 1.732050808757. Root 5 will come 2.23606797775. In the same way, root 7 also value will come 2.64575131106 and so on. So, what we need to observe here, they are not terminate, as we have learned that they neither be expressed as terminating decimal, so they are not terminating. Then second type we have learned under rational number, that repeating decimals. Are they repeating decimals? Just look at here, 1.4142135627. Now some students will say, sir, 4 is repeating here. No, this is not called repeating decimals. It will be called repeating decimal if it will be like 1.444444 like that, or you can say 0.4444, only 4 is there, then we can say yes, it can be repeating decimal. So here you can see 4, then comes 1, then comes 4, then after here 4 1, here 4 2 comes, then 1, then come 3, then 5, then 6, then 2, then 3, then 7. So there is a no digits which is repeating itself, or you can say there is no digit which can there is no set of digits which are repeating itself continuously. Okay, so we can say that it is neither a terminating or nor a repeating decimal. So this type of numbers which are non-terminating, non-repeating are called irrational number. So root 2 is a irrational number, root 3 is a irrational number, root 5 is a irrational number. Okay, now I hope you are familiar with this symbol. What we call this symbol? We call this symbol as pi. Now we have learned in our 8th standard the approximate value of pi is 22/7, or we can say 3.14. You have learned or not? We have learned in our previous classes, 8th, 7th and even in 9th starting chapters, we have learned that pi value is what? 22/7, or we can say 3.14. But it is approximate value. It is not the exact value of pi. We can't say that it is the exact value. It is not a exact value of pi. The exact value of pi is what? 3.141592653589793238462643338 and so on. I know it is very long. Okay, so this is the real value of what? Exact value of what? Pi. And if you observe this, you will find that it is what? It is also a what? Non-terminating and non-repeating. It is what? Non-terminating decimal and non-repeating decimal. And we have learned just before, we have learned that a number which is non-terminating and non-repeating is called what? Irrational number. So here we can say that if it is given to us in a 1 marks question that what is pi, so we can say pi is an irrational number. Or what? And if we talk about 22/7, then we can say 22/7 is a rational number, because 22/7 satisfying the 3 rules that it can be expressed in the form p upon q, where q, that 7, is not equals to 0, and 22 and 7 both are integers. Okay, I hope it is clear to you. So pi is also a what? Example of a irrational number. Then comes, are the square roots of all positive integers irrational? Just we have learned earlier that root 2, root 3, root 5, root 7, these all are what? Irrational numbers. So in this way, if we put a square root on all the positive integers, okay, like 2, 3, 4, 5, 6, 7, 8, 9, 10, so what will happen? They all will become irrational. Just think about that. Then I am explaining you here. Just pay attention. First we'll take the example of positive integers. Like positive integers can be 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. These all are what? These all are what? Positive integers. 11 also can come here, okay? Don't be confused. These all are what? Positive integers. Now out of these, what are the perfect squares? Now what is perfect square? The number when we multiply by itself, so what we get in the result? Perfect square. Like just look at here, 2 square, it means 2 multiplied by 2, number multiplied by itself, so what we are getting? 4. 3 multiplied by 3, so what we are getting? 9. 4 square means 4 multiplied by 4 itself, so what we are getting? 16. 5 multiplied by itself, so what we are getting? 25. So 4, 9, 16, 25, these all are what? Perfect square. Okay, 4, 9, 16, 25, these all are what? Perfect square. Now if we talk about 2 is a perfect square? No, there is no number like that, such that we multiply by itself, so it will come 2. Okay, it is not like that. Okay, these numbers are only what? Perfect squares. 4, 9, 16, 25, because these are the result of multiplication of a number by multiplied by itself only. Okay, so what we are saying? Perfect square. So if we check who are the perfect square in this one, so 4 is a perfect square, 9 is a perfect square, then we can say 16 is a perfect square, and if we move forward, so what will come? 25 is a perfect square, then 36 is a perfect square, then 7 7 is a 49, so 49 is a perfect square, 8 8 is 64, 64 is a perfect square, 9 9 is a 81, 81 is a perfect square, and 10 10 is a 100, so 100 is also a perfect square. In this way we can move forward. Okay, then these all are what? Perfect square. Till here I have just taken few example. Okay, it can be more also. Now who are not perfect square here, which are left, like 2 3 5 6 7 8 10 12 13 14 15, these all are what? Not perfect square. You can say non perfect square. These are not perfect square, these which are left, which are uncircled. Okay, this circled one perfect square, which are not circled, they are not perfect square. Now what is the rule? We are coming to the question that are the square roots of all positive integers irrational? So we are just trying to give the answer of this question. What is the rule? Rule says that if m is a positive integer, m is a variable. What is this m? It is a variable. Okay, so if it is a positive integer which is not a perfect square, what I am saying, which is not, that's why I have written with the black pen, which is not a perfect square, then only what will happen? If we square root of that number, so it will become a irrational. Like, who are their numbers, positive integers, which are not perfect square? 2 is not perfect square, 3 is not perfect square, 5 is not perfect square, 6 is not perfect square, and so on. If we put square root on this number, so what will happen? They will become irrational. Like root 2, root 3, root 5, root 6, root 7, root 8, root 10, root 11, root 12, root 13, root 14, root 15, and so on. These all are what? They become irrational numbers. Now questions come, sir, root 4 also become a irrational number? No. 4 is a perfect square. It can't be a irrational number. Then questions come, sir, why it can't be a rational number? Just look at here. We can write root 4 as under root 2 into 2. 2 2 is 4. It will become root 4 only. Now here see what comes? The pairs of 2. When the numbers comes in pairs, so we can remove the under root. So what comes? Value came 2. So it means the square root of 4 is what? 2. And 2 is not a irrational number. In fact, 2 is a rational number. That's why root 4 can't be count as a irrational number, but root 4 will count as a rational number. Clear to you or not? So those who are perfect square, like you can see perfect square, in this way root 9 is also not a perfect square. Root 9 is also a rational number, because root 9 equals to what? Root 9 equals to 3. So 3 is a rational number. It is a rational number. Okay. In this way, we can say root 16, 4. So that is also a rational number. Root 25, 5. So that is also a rational number. So I hope it is clear to you. Now what they ask? Are the square roots of all positive integers irrational? So what we can say? No. The square root of all the positive integers is not irrational. For example, we can say, we can give, like we can say, like 25 is a positive integer, and if we square root of this, so what will come? 5, which is a rational. Okay, that's why we can say the square root of all positive integer is not irrational. Okay, but those positive integers who are not perfect square, those square root is what? Irrational number. Clear to you? Now look at these numbers. Identify whether these decimals are irrational or rational. Like first one, 0.1011011101111, then 0, and so on. Just identify whether this come under the category of rational or irrational. Like we have learned under rational number the terminating decimals. So are they terminating? No, they are not terminating. They are continuing. Okay, so they don't come to an end. So the second type we have learned under rational number, that is what? Repeating, or you can say recurring decimals. So here the digits are repeating continuously. Now the students will say, sir, here 1 is repeating. Just see, here 3 times, here 4 times, here 2 times. No. If it is like 0.11111, then we can say yes, it is an example of rational number under what? Repeating or recurring decimal. But here it is not an example of rational number, because here 1 is not repeating continuously. Just check here. Here 1 how many times comes? 1 time. Then 0 comes, then how many times come? 2 times. then here comes how many? 3 times, then here 1 2 3 4 times, and after 0 again it will come how many? 5 times. So it is an example of irrational number only. In the same way, just check the second example, 0.02200, then 200, then 240, then 2 and so on, then 250 will come and so on like that. So here you can see, here also that you will say that sir 0 is repeating. No, 0 is not repeating continuously. See, after 20 2 comes, then after 2 then 30 came, then it is 40. It is not the same number. How if it is like that, 200 then 200 then 200 then 200, then we can say, but here they are not repeating continuously. 200 then 2000, then it becomes 20,000, then it becomes 2 lakh. So it is an example of what? Irrational number. 1211, how many times? Double 1. Then what? Triple 1. Then 1 2 3 4, 4 times 1. So it is also not a rational number. These all are the example of what we can say? Irrational number. Okay, these all are what? Irrational. So when you are observing these type of numbers, so don't be confused. Okay, clear or not? Now we will learn the most important, that is properties of irrational number. These are very important because many times these are coming under the marks like 1 marks, and sometimes in questions also they are helping. Okay, so first property of irrational number: irrational numbers satisfy the commutative, associative, distributive laws for addition and multiplication. Now I am not going to revise this commutative property and associative property and distributive properties, because these properties we have learned in previous classes like 6th, 7th, 8th. You are learning every year. Okay, so we are talking about what? Irrational numbers satisfy. We have learned about closure property also, but here closure property is not, I have not mentioned closure property because irrational number don't satisfy closure property, but it satisfy commutative. Commutative property means order change but answer remains same. Okay, associative, grouping change but answer remains same. Distributive, one is distributed to others. Okay, but for whom? For addition and multiplication only, not for, you can say, subtraction, and not for division, only for addition and multiplication. For example, I can say root 2 plus root 3. These two are what? You can say irrational numbers. So root 2 plus root 3 equals to what? Root 3 plus root 2. What we are doing? We are changing the order. First we have written root 2 plus root 3. Here also the same numbers, but what happened? This time I have written root 3 first, then plus root 2. So it will not change the result if I change the order. So it will remain same, root 2 plus root 3, root 3 plus root 2, root plus root 2. It will remain same only. Okay, the same will give same answer. This is called commutative property. So here the rational number satisfying this property. And if we check the commutative property under multiplication, here we have checked under the addition. Now check under multiplication. We know that if you multiply root 2 into root 5, so what will come? 2 into 5, 2 and 5 will come under one root, and then root 10 will come. Use this property here. Okay, look at here. Root 2 into root 5. Root 2 is an irrational number. Root 5 is also an irrational number. Now you're multiplying in another way. Now we have written root 2 first. Now we are writing root 5 first. Root 2 into root 5 equals to root 5 into root 2. What will come? 10 only. Root 10 left hand side, then root 10 right hand side. So the answer remain same only. So we can say that irrational numbers satisfy these properties under addition and multiplication. Then comes second property, that sum of two irrational numbers need not to be an irrational. It is not necessary that whenever we add two irrational numbers, the answer will be always irrational. No, it is not like that. Sometimes it can come what? Rational also. How? Just look at here. 2 plus root 3 is an irrational number. Yes. 4 minus root 3 is an irrational number. Of course. Now just add them. We are finding their sum. So 2 plus root 3 plus 4 minus root 3. Now 2 plus root 3. So what? Plus 4 minus root 3. So what we can do? First we are adding whole number. So 2 plus 4. Then root 3 minus root 3. So 2 plus 4, 6 came, and root 3 minus root 3 cutted. So what left? 6. And 6 is a rational number because we can express as 6 upon 1 also. Clear or not? So it becomes an rational number. Clear to these two properties? Now move to property number second under second property. Second property, first part we have learned. Now we learn about second part. Second property says that difference of two rational numbers need not to be an irrational. Okay, so it is not necessary that whenever we subtract two rational numbers, so difference will be also always comes irrational. It is not necessary. How? Just look at here. 7 plus root 2 irrational, and 5 plus root 2 is also an irrational number. Now let's subtract them. So 7 plus root 2 minus 5 plus root 2. 7 plus root 2 is written on left, so it will remain same. But when we open bracket here, so what will happen? This this 5 is of positive sign, it become negative minus 5, and then plus root 2 become plus minus minus root 2. So what happens? 7 whole number, then what is the next whole number? 5 minus 5, written minus 5, root 2, then minus root 2 minus root 2, root 2 minus root 2 cut it, what left? 7 minus 5, it means 2. And again 2 is a rational number because we can write it or express as 2 upon 1, which is a rational number. So it satisfies this one. Okay, now third property says that product of two irrational numbers need not to be an irrational. It is also not necessary that whenever you are multiplying two rational numbers, so the result always come an irrational number. It is not necessary. How? Just look at here. Root 5 multiplied by root 5. What will come? 5 only. Now some students are writing root 25. I know that many students are writing like 5 multiplied by root 5 multiplied by root 5. They are writing under root 25. That is wrong. Because what happened? Here becomes what? Pairs. Just look at here, rough work. When you are multiplying root 5 multiplied by root 5, so what will happen? It becomes pair, 5 into 5. And when pair becomes, what will happen? The under root will remove. So what will come? 5 only. And 5 is a rational number. Okay. So we have learned that it is not necessary that when we are multiplying two rational numbers, always the answer always comes irrational. It can come rational also. Then come for division. All rules same for all operations. Now for divisions. Quotient of two irrational numbers need not to be an irrational, like 7 root 8 irrational, root 8 irrational. If we divide 7 root 8 by root 8, so what will happen? We can cut root 8 from root 8, so what left? 7, which is a rational number. So these are what? Properties of rational numbers. Okay, these all of the subparts of second property. Now we'll learn about third property. Now third property we will learn. Under third property, first part we will learn that sum of a rational and an irrational. Now here just pay attention that we are not talking only irrational, but we are talking about rational also. When we are adding one rational and an irrational number, so what will happen? Just check. 2 rational number, root 3 irrational number. So what will come there? Addition. There's sum 2 plus root 3, which is called a irrational. So sum of a rational and irrational number always comes an irrational. Okay. Then difference of a rational and an irrational, like 7 is a rational number and root 2 is an irrational number. If we subtract them, so what will come? 7 minus root 2 only, because we can't subtract them because it is a what? Whole number, it is a under root number, so we can't subtract them. So what comes? Irrational only. This is also called a irrational number. Okay, so we can say difference of a rational and irrational always comes an irrational number. Now product of a rational and an irrational. Now product 12 is a rational number, root 3 is an irrational number. If you multiply, what will come? 12 root 3, which is also a irrational number. Okay, so product also rational number, product also irrational number of what? Rational and irrational. If we find difference of a rational and irrational, that will be also rational. If we find sum of a rational and irrational, that will be also come irrational. Now check the division part. Quotient of a rational and an irrational is also what? Irrational. How? Rational divided by rational. So 6 is a rational number because we can express as 6 upon 1. Then root 6 is a irrational number. So rational divided by irrational. So we can write 6 as root 6 multiplied by root 6, because when you multiply root 6 into root 6, so what will come? 6 only. Okay, I have explained earlier. Then downside root 6. So from root 6 we can cut this root 6. So what left? Root 6. And root 6 is a what? Is an example of irrational number, because 6 is a positive integer which is not a perfect square. So we can say yes, these all properties satisfied by the rational and rational properties under rational and irrational properties. So we can use this property to find out our answers when in future we are getting the questions. Okay, so I put it clear to you, students. So as we have completed our class, so I will assign some questions to you. Okay, so you can do by yourself those questions, just try yourself. Okay, and if you don't understand, then again watch the video, again check it properly. Okay, and I will assign some questions from NCERT also, like 1.2 question exercise. You can see question number 1 and question number 2. This 1 and 2 question you try by yourself. 3 and 4 question I will explain you in next video. Okay, and I will assign some extra questions also which you can solve by yourself. And one more thing, if you like the video, suppose that this video is helping you, you understand it properly, so just click on the like button also. Okay, thank you, students.
At last, I just want to say be safe and God bless you all.